Welcome to section 4.1. What is a method? In this lesson, we're diving into a fundamental concept in Java programming, methods. You'll see how they help us structure code, reuse logic, and interact with objects in a clean and powerful way. Here is what you'll learn today. How to organize code using classes, create objects, understand and use methods, pass values into methods, access methods and fields using the dot operator, and even return values from methods. Basically, everything you need to start writing smarter Java code. In Java, you'll encounter tons of classes, some written by you, others by your team, or the Java language itself. Each class can represent an object type, and it will usually contain two key parts, fields and methods. Fields hold data and methods define behavior. Today's focus is the method side of things. Think of a class like a blueprint. It outlines what an object has, that those are its properties, and does its methods. Once you understand how to use methods in a class, you can interact with almost any Java object, whether it is from your own code or from the language itself. All right, let's make this real. It's Alex's birthday, and your group of 8 friends just wrapped up dinner. But when the bill arrives, nobody knows how much they owe with tax and tip included. Lucky for everyone, you've been learning Java and brought your laptop. You create a new Java project and load up tip01.java. The pre-tax amounts are listed for each friend. Your mission: write a program that calculates and prints everyone's final total after adding 5% tax and 15% tip. Here is the expected output. Each person's total bill should be displayed after adding tax and tip. Your goal is to get your program to generate this exact list. Now, your first instinct might be to calculate each total individually, like total 1 equals person 1 times, in parentheses, 1 plus 0.05 plus 0.15. That works for 1 or 2 people. But if you copy-paste that logic for every guest, it gets out of hand real fast, especially if you have 100 or 1,000 people. Not to mention how hard it'd be to fix an error or update the formula later. You might never have 1,000 dinner guests in real life, but there are other scenarios where 1,000 objects make sense, like a bank with 1,000 savings accounts. This is where variables already help. If you change the tax or tip, you only need to update it in one place. That's a nice start, but we can take this flexibility even further using methods. Instead of repeating the same calculation over and over, we'll write a method once and call it whenever we need it. Cleaner, simpler, and way more scalable. So, when should you write a method? Easy. Anytime you're repeating similar code, especially calculations, or when you want to describe something an object can do, it's a great way to break your program into meaningful pieces. A quick word about main method. It's like the conductor of your program. It tells Java where to start and how to execute the code, but it's not the place to describe object behavior. Leave that to your other methods. Let's talk structure. Your classes should separate fields and methods clearly. You will see how we evolve our code into a clean format that follows this blueprint with fields up top and behaviors or methods down below. Step 1. Move your reusable values like tax and tip out of the main method and make them class fields. That way, they are easier to manage and reuse. Step 2. Wrap repeated behavior like total calculation into its own method. Maybe find total. That makes your code reusable and tidy. Step 3. Once all behavior is handled by your custom methods, you can even remove the main method from that class. then call it from another class that drives your application. Great. You've got a clean class, fields for data, methods for behavior, and no redundant code. So where does the main method go now? In a separate class like calculator test. That's where you create objects and tell them what to do. Think of it like the remote control for your calculator object. Just like with primitive data types, you use variables to represent objects. You'll usually need the new keyword to create instances, though there are some exceptions like strings. You use the dot operator to call methods or access fields from an object. For example, calc.findTotal runs the findTotal method, and calc.tip equals or assign 0.10 updates a field. In exercise 2, you'll practice using the dot operator and your own methods to calculate totals for each dinner guest. Try changing values and see how your output updates. Eventually, you'll learn to pass values as arguments into your methods, like the original price or even the person's name. That will let you do the same work in one line. You might start out writing 2 lines per guest, one to set the price, one to call findTotal. But there is a better way coming. Remember, jOptionPane.showInputDialog. That's a method too, and it uses an argument to customize its prompt. Arguments change what a method does. But not all methods accept arguments unless they are written true. If a method expects no arguments and you give it one, Java is gonna complain. Here is a correct example. This calculate method expects an int and a double. So calling calc.calculate 3,2.0 works great. It will print 1.5. But argument order matters. Flip them around and Java freaks out. It won't convert a double into an int. Always match the order and type exactly. In exercise 3, you'll start modifying your findTotal method to accept arguments. This lets you customize the behavior based on input values. You'll then add another argument, the person's name, to personalize the output. Java will guide you through the adjustments with its helpful errors. Here is a good reminder. Arguments are the values you pass into a method. Parameters are the variables in the method's declaration that receive those values. They live inside the method and can be used throughout its block of code. In this example, 3 and 2.0 are arguments passed to be the values of x and y within the calculate method. Methods can take any number of parameters and use these values within the method code block. Now let's talk about scope. A parameter only exists inside the method it was declared in. Try using it elsewhere and Java will complain. It's like trying to use someone's house key in the wrong house. Now, Alex asks, what's the total for the whole table? It's a good question. But there is the issue. Your method calculates totals, but doesn't return them. You've probably written something like system.out.println calc.findTotal of 10 plus calc.findTotal 12. But Java yells void type not allowed here. That's because findTotal doesn't return anything yet. It is a void method. Void methods don't give anything back. If you write the code as in the slide, you are partly correct, but Java throws an error. Methods like showInputDialog they return a value you can store, like a string. If you want to use a method's results, it can't be void. To return a value, change your method from void to a return type, like double, and use the return keyword to send the value back to the calling method. Void methods don't need a return statement. Void methods are incapable of returning a value in Java, although they can have a return statement. The type of value that a method returns must match the declared return type. For example, a Boolean type method must return a Boolean. A string type method must return a string. In the top example, num1 and num2 are added together. In the bottom example, this logic is put into the sum method. Values are passed to the sum method and added. The resulting integer value is passed back and assigned to the result variable. For now, ignore the static keyword in the sum method. Here is how it works. When you pass values into a method, they get assigned to parameters. Inside the method, you calculate a result. Then that result gets returned back to wherever the method was called. Exercise 4 will have you return the calculated total and store it. From there, you will add the values together to get the grand total for the table. It's also possible to find the total by creating a field within the calculator class and adding to it each time you call find total. However, it isn't always, but sometimes it's desirable to store a calculated value as a field. This field could also be tampered with. The total could be incorrect if someone wants to refresh their memory and check their individual total again. And if we chose that solution, we wouldn't have any reason to show you how cool it is for methods to return values. But wait, person 8 forgot their wallet, and Alex's meal was supposed to be covered by the rest of the party, so you'll modify the program so the cost is shared evenly. Bonus logic challenge. Before we finish, here's a little review of method syntax. When you write a method like this, public double calculate in parentheses int x comma double y, you're saying the method will return a double. It takes two parameters and do some calculation. To wrap up, you've now seen how to write methods, supply them with arguments, receive return values, and use them to structure smarter, more scalable programs. That's a huge step forward.